we've been talking about the idea of sequences. Now let's expand that to the idea of a series. Now, what is a series? First of all, I want you to think in terms of grade school addition. I have a series of ones. Now, if I take the first two values in that series, 1 plus 1 equals 2. All right? Now, if I add the next one onto it, I have 1 plus 1 plus 1, which I could think of as being 1 plus 1 plus 1, which is the previous 2 plus 1, which is obviously 3. Now, the next one, if I add yet another 1 onto it, I'll have 1 plus 1 plus 1 plus 1. See, this is the previous one right there, which is obviously 3 plus 1, which equals 4. Now, adding these up is really pretty simple, because what we have here is the addition of finite terms. Okay, adding finite terms is a piece of cake. Just keep adding them up. Now, where we get into trouble, or where things start to become somewhat confusing, more challenging, is if we have the addition of infinite terms. Okay, so just consider a sequence that looks like 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so forth. I'm going to add these up, and this goes out to infinity. Well, pretty clear that 1 minus 1 is 0. 1 again minus 1 is 0. 1 again minus 1 is 0. So I'm going to have this infinite number of zeros. So if I simply add them all up, clearly this will sum to 0. Okay? Well, what if I do this? What if I take this same sequence and I'm going to skip the first term, and now I'm going to add up all these. I'll have 0, 0, 0, 0, and so forth. So clearly, as I go to infinity, this will sum to 1, because I have a 1 and a bunch of zeros. Well, what if I, rather than taking these 1, negative 1, 1, negative 1, what if I just take all of the positive ones and move them up front? So I'll have 1 plus 1 plus 1 plus 1 out to infinity. And then all the negative ones, I'm going to put it at the rear. So I'll have negative 1, negative 1, negative 1, negative 1, negative 1 out to infinity. So what I end up with is infinity minus infinity. Well, clearly, infinity minus infinity equals, I don't know what that equals. Don't be saying 0. Okay, that's kind of, which of these, which is correct, if any of them? Well, that is going to be the main topic that we're going to be covering here for quite some time, looking at the idea of different types of series. Can we sum up some series? Can we figure out what the sum actually is? Can we determine if this series is convergent, if it actually sums to some number, even though we may not be able to figure out what that number is? Can we estimate that value within a certain amount of error? Also, one more thing just to note, well, hold on to that thought. Notation-wise, let's continue here for just a second. If an is an infinite sequence, then the sum n equals 1 to infinity of an is known as an infinite series. Now, infinite series are often simply written as a sum of the an's rather than saying n equals 1 to infinity. We kind of assume that we're always talking about n equals 1 to infinity. Our domain is 1, 2, 3, 4, 5, unless we otherwise specify. Sometimes we do actually take series that n equals 0 to infinity. Now, go back to what I had here just a second ago when I was adding these up. 1 and 1 is 2, 1 and 1 and 1 is 3, and so forth. If I take S1, I say that equals A1. So that's the first term in my infinite sequence. S2 equals the first term in the infinite sequence plus the second term. So S2 is the sum of the first two terms. S3 would be the sum of the first three terms. On out to Sn, which is the sum of the first n terms. Now, we think of Sn as being the partial sum. It's the sum of the first n items or elements of the series. So I'm adding up all of these pieces of the sequence. So the sequence itself, Sn, because this will result in a sequence, all these S's, is actually the sequence of partial sums. Each one of these, S3 would be Sn, where n equals 3. So that'd be the third partial sum. Now, just notation-wise, depending on the book we're using or the edition, very commonly Tn may be used as the partial sum. Different books use different types of notation, but typically it's that type of notation. Both Sn and Tn are both partial sums. Okay, so that should serve well as a basic introduction to what we're going to be talking about in terms of infinite series. We've been talking about infinite sequences. Now we're going to take those sequences and add them up, those values, and that's going to give us an infinite series.